Section 2.5 is on algebraic proofs, and a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So today we're going to look at algebraic equations that you already know how to solve, but we're going to prove that our answer we get is the correct answer by using all of the different properties that we know about. So here is a list of the properties. They are all given to you with examples of A and B and then a C thrown in. So the addition property of equality says if A is equal to B, then A plus C equals B plus C. So that is just saying we can add the same number to both A and B and still have the same answer. The subtraction property of equality, again, if A and B are the same, if they're equal, if we take C away from both of them, then we will still have the same answer. And the multiplication property of equality is the same thing again, except for we're multiplying by C for both letters A and B and have the same answer that are equal to each other. Then the division property of equality, A and B are equal to each other. The only stipulation here is that C cannot be 0 because we cannot divide by 0. But if we divide both A and B by C, then we still will have the same number. The reflexive property of equality is where A is equal to A, so any number is equal to itself. The symmetric property of equality is if A is equal to B, then we can flip it around and say B is the same as A. And the transitive property of equality is if A equals B and B equals C, then A and C are equal as well. So if A was 1, then B would be 1, and if B is 1, then C has to be 1. So kind of like those if-then statements that we were looking at last week. Substitution property of equality. If A and B are the same, then B can be substituted for A in any expression. All right, if you start with a true statement and each logical step is valid, then your conclusion is valid. So if we start with something that's true and we prove each step works based on one of those properties, then we know that our answer is valid. So example 1, we need to solve the equation. -5 equals 3n plus 1. So I'm going to start off by rewriting that down here. We have to prove each step. So this first step is given. That is what they gave us to solve. So that's our given statement. Then we are going to solve this, have to subtract 1 from both sides. So if I take 1 away, if I subtract 1, what property up here would be being used? So that would be the subtraction property of equality. It says that if two things are equal, for A and B here, then we can take C away from each and still have the same answer. So this is the subtraction property of equality. I'm subtracting 1 from both of our numbers, A and B. So you can kind of think this side would be A and this side would be B. So this is the subtraction property of equality. And when I do that, we got to go -5 minus 1 would give -6. And then over here, we would just have 3n. And for our answer over here on the side of our list of properties that we are using to prove our work, we are just going to say this is simplified because that's all we did. We didn't actually do anything but simplify there. So then we have to do one more step to solve. We're going to have to divide both sides by 3. And if I go back up here, what property says that I can divide both A and B by a number and still have the same answer? So that would be the division property of equality. So our proof here is the division property of equality. And then when we actually do that, 3's cancel here. We have just n. And negative 6 divided by 3 would be a negative 2. And that is simplifying as well. And then normally we write our answers n equals, so we're going to flip this around, n equals negative 2. And I have to prove why I did that as well. If you look up here, flipping them around is the symmetric property of equality. It says if A equals B, then B equals A. So it just means that I can turn them. So this is my proof for doing that, is the symmetric property of equality. Example 2 says to simulate the motion of an object in a computer game, the designer uses the formula S times R equals 3.6 times P to find the number of pixels the object must travel during each second of animation. In the formula, S is the desired speed of the object in kilometers per hour, R is the scale of pixels per meter, and P is the number of pixels traveled per second. So the graphics in a game are based on a scale of 6 pixels per meter. The designer wants to simulate a vehicle moving 75 kilometers per hour. How many pixels must the vehicle travel each second? Solve the equation for P and justify each step. So our starting equation is S times R equals 3.6 times P. And it says S is the desired speed of the object. And they said that was 75. So I'm going to put 75 in here for S. R is the scale in pixels per meter. And they told us down here that that was 6. So R is going to be 6 equals 3.6. And here's that 75. How many pixels must the vehicle travel each second? And P is the number of pixels traveled per second. So we have to solve this for P. So our proofs over here, this was given to us. And then I plugged in numbers. So if I go back and look at our chart, which one talks about being able to plug in numbers or substitute numbers? That would be the substitution property of equality. It says if A is equal to B, then B can be substituted for A in any expression. So we can replace those. So this is the substitution property of equality. And then over here, we're going to have to simplify 75 times 6, which is 450. And that equals 3.6p. So my proof for that is just simplify. And then we're going to have to divide each side by 3.6. And remember, if I'm dividing both sides by the same number, that would be the division property of equality. And the 3.6 is canceled. We have P equals 450 divided by 3.6 is 125, not 100. There we go. So that was a simplify. And just like the last one, we have to flip them around. And that was called the symmetric property. And I can't spell. Moving on, example 3, write a justification for each step. Km equals KL plus LM. And the proof for this Km equals KL plus LM is the segment addition postulate. That is something that we talked about in chapter 1. So if you still have those notes, you might want to pull those out and find all those postulates that we talked about. If not, I will post a document here on Canvas with all of those on it as well, because you are going to need all of them. So now we're going to plug in the numbers. Km, oops, I guess I didn't label the line. M is the entire length, so that's 5x minus 4. KL is x plus 3. And LM is 2x minus 1. And we substituted numbers or expressions in, so that is the substitution property of equality. And next, we are going to add together like terms here on the right-hand side. So x plus 2x would go together, and that would make 3x, and then a positive 3 and a negative 1. Positive 3 minus 1 would be a positive 2. And over here, we still are going to have 5x minus 4. So that is just simplify for my proof. Then we're going to subtract 3x from both sides. So we have 2x minus 4 equals 2. And, we subtracted from both sides, so I can't forget to keep up over here. So that's the subtraction property of equality. And I don't mind that you abbreviate over here, but don't write SUB because it could be the substitution or the subtraction. So make sure you have enough letters to distinguish between the different properties. And then I had already simplified here as well. And then we're going to add 4 to both sides. So that would be the addition property of equality. And then we would have 2x equals 6. So that's just simplify. And then we're going to divide by 2. So that would be division. And then we'd have x equals 3, and that's simplify again. 3 more properties to look at, but because my video is already at 14 minutes, it's going to stop recording at 15, so I am going to have to make 2 videos for this.